Hi, today I'm going to be talking about building zero-dependency CLI apps with Node.js. Before we get into that, let me quickly introduce myself. My name is Ian Sutherland. I'm the head of developer experience at Neo Financial, which is a Canadian fintech startup. I'm also a Node.js contributor where I primarily work as a part of the tooling working group, and I'll get into that a little bit more in this talk. I'm also one of the maintainers of Create React app, and you can find me online on Twitter or GitHub at IanSu. That's IANSU. And if you have any questions or feedback about this talk or about anything else, I'd love to hear from you. Okay, back to zero-dependency CLIs. Here's a quick overview of some of the things I'm going to cover in this talk. What are dependencies and why are we trying to avoid them? What is a CLI app and why are we talking about them? What new Node.js features can help us write CLI apps? And what new Node.js features might be coming next? Let's start with dependencies. What are they and why do we need them? A dependency is some other piece of code, like a library, that your program needs to run. In Node.js, dependencies commonly come from and are installed with npm. Other users and contributors will also need to install the same dependencies. Dependencies need to be installed at build time and deployed with your code. Node.js does not include a big standard library and relies on npm packages instead. Node has a particularly small standard library, and an early architectural decision was to have a small core. This made packages on npm the choice for any additional functionality, and is why we see packages like isNumber with millions of weekly downloads. So, are dependencies bad if we don't want to have any of them? Not necessarily. Dependencies do introduce some overhead in the development and deploy process. As I mentioned before, users need to install the dependencies to run and develop on a project, and dependencies also need to be installed or bundled at build time. If you're building a complex app, it probably already has a build and deploy pipeline and many dependencies, so adding more dependencies probably doesn't make much of a difference. For smaller apps and libraries like CLIs, not having an install or build step makes setup, contributing, and distribution easier. So, CLI apps, what are they and why do I keep talking about them? CLI stands for Command Line Interface. It's basically just a fancy way to describe a script that takes some input and generates some output. These kind of apps run in a terminal environment, and they're commonly used for dev tools, build scripts, and other kinds of process automation. They range from very simple, like cat, which is a program that just displays the contents of a file in the terminal, to very complex, like git, which has many different subcommands, and those subcommands take all kinds of different arguments and options and inputs and outputs. Here's an example of the ls command. This command just lists the contents of a directory. Here's another example of a more complex CLI. This is git. I've run git status here, and so it's showing me which files are modified in my working copy. So why am I talking about CLIs? Well, I work on a number of CLI apps as a part of my job and use them daily. Also, I just really like CLI apps. They're fun to build, and the terminal is a challenging, somewhat constrained environment. The things I'm talking about here don't just apply to CLI apps, though. There are other types of apps that also benefit from having no dependencies or build and deploy steps. Those include things like serverless functions, build scripts, and GitHub Actions. So now that we've covered a bit of background, let's take a look at what's new in Node.js, specifically Node 18.3.0, which, as of the time of this recording, came out last night. So definitely cutting it a bit close here with this talk. First, let's talk about argument parsing. Simple scripts often don't take any inputs. As they get more complex, it becomes helpful to accept some user input. This also helps make scripts more general and useful in more cases. Most languages provide at least a basic argument parser. Now, argument parsing is something the tooling group has worked on for a long time. Lots of different people participated in shaping the API and implementing this feature. I helped a tiny bit, and I'm one of many people that worked on this. So parsing arguments is surprisingly complicated and can be tedious and error-prone. Let's take a look at an example. So here we're calling a CLI called myCLI, and we're passing it a -- silent flag. In this next example, we're just passing a -s flag, which is a short version of the silent option. In this next example, we're passing the -- silent flag, and we're saying it equals true. In this next example, we're passing the same flag, and we're saying its value is false, except note that we don't have the equal sign there this time. And then in the last example here, we're passing a slightly different version of the flag. It's -- no - silent. And all of these basically do the same thing. They set the silent argument, but in several different ways. And this is just one simple example of argument parsing. And you can see there's already quite a lot of different ways to do the same thing. So how did we used to handle this? Or more accurately, how are we handling this currently? In your Node application, there's a variable on the process global called argv, and that's an array of strings. So whatever you pass on the command line gets split anywhere there's white space and turned into an array. Here's the array of strings we get for our first example. You'll notice the first element in the array is always the node executable, followed by the name of your script, and then all of the arguments following that. So in this example, the -- silent flag is the third element in the array. In the next example, we just passed -s, and so you can see that as the third element in the array. Then in the next example, we passed -- silent equals true, and because we didn't use any white space around the equals sign, you'll notice that all of that ended up as one string. In the next example, we passed -- silent space false, and because of that space, the flag silent and the value false are now split into two different array elements. And then in the third case, we just passed the -- no silent flag, which you see at the end there. Even with this simple example, you'll notice there's quite a few edge cases. So more likely you're going to use a third-party library like Yargs or Commander to handle all of these different situations. But now there's a new way to do this in Node.js, introducing util.parseargs. So the first thing we're going to do in this example is import parseargs from node::util. And you'll notice I'm using this node: syntax in the rest of this presentation. That was introduced a couple versions ago. And the idea there is it just lets you disambiguate internal Node.js modules from third-party modules on NPM. So next we grab the process.argv argument again. This time we're going to just remove the first two values. The first two values are usually just the node executable and the name of the CLI. So we're going to get rid of those. We only want the arguments that are passed to the CLI. And there is actually another proposal being worked on to define something called process.mainArgs, which would essentially do this for you, because sometimes there's two things you have to slice off the front, sometimes it's three. So the idea is that would just take care of that for you. But in the meantime, we'll just do it ourselves here. And then next, we're going to define the options that our CLI takes. So here we're saying we have one option. It's called silent. It's of type Boolean, and its short equivalent is the letter S. And then finally, we just call the parseargs function, and we pass it the input that was sent to us on the command line and the options that we've defined. So what is this going to produce? Well, using the previous examples, this is what we're going to get from parseargs for each case. So in the first case, we passed -- silent. So you can see we get an object where silent is true. In the second case, we passed just -s. And so you can see that gives us the same thing, an object where silent is true. In the third case, we passed -- silent equals true. And we're actually getting an error in this case. Because we define silent as a Boolean option, the error is telling us that it actually doesn't take an argument. If it's present on the command line, that's true. And if it's not, that's false. So we get an error in that case. And then we get the same error in the fourth case where we passed -- silent space false. And then finally, for the last option, we get another different error that says unknown option -- no - silent. So parseargs does not automatically create these options that start with the no prefix for us. You could certainly add those yourself. And if that's something that is really important to you, you may want to use a third-party library to support that. But you will notice that in each of these error cases, we get a pretty good and clear error message from parsargs that would be suitable to display to the end user. Next up, let's talk about fetch. Fetch is a web API for making HTTP requests. People have been attempting to make fetch happen in Node.js for several years. I have to show the obligatory "stop trying to make fetch happen" GIF from Mean Girls. Fortunately, we didn't listen to that advice, and fetch is now available in Node.js 18. Fetch is built on top of Undici, which is a new HTTP 1.1 client written from scratch for Node.js. Fetch is also built with the Web Streams API, which is also now available in beta in Node.js 18. So let's take an example of using fetch to query the GitHub API for my profile information. So you'll notice we're not actually importing fetch in this script. Fetch is actually available globally. You don't have to import or require it from anywhere. So the first thing we're going to do is just say response equals await fetch, and then we're going to give it the path to the GitHub API, and specifically the users/ensu endpoint. And then the next thing we're going to do is just await the response.json method. So the first method makes the request and gets us a web stream back. And then the second method here streams the body response and converts it into a JSON object. And then if we take a look at that object, we're just going to see it's got my GitHub login, name, company, and some other information that I removed from the screenshot. So there you go. It's that easy to make a basic API request now in Node.js. Next up, let's talk about the test runner. The test runner is a basic API to create tests, both synchronous and asynchronous tests. It supports subtests and also supports skip, to-do, and only annotations on tests. It can be used with Node's existing built-in assert library. And it also includes a simple runner to actually run the tests that you've written. And you can provide the runner with a list of files. It will also automatically run all the files in a test directory. And it will also automatically run files that end in .test.js, .test.cjs, and .test.mjs. So let's write some basic tests. So the first thing we're going to do is import test from node:\test. And I mentioned earlier that this node: prefix is a way of identifying built-in Node modules as opposed to modules on NPM. One thing that's important to note with this test runner, this is the only way to import it. You can't just say import test from test. You must specify node:\test. And so that's why I'm using this syntax throughout this talk. It's probably just a good habit to get into doing that in all of your code from this point forward. So, okay, we import the test function. Let's also import assert from node::assert. And then here we have an example of writing a synchronous test. So we just say test, and then we pass it a string, which is the test identifier. And then this is just a basic test. We're just saying assert strict equal the number 1 and the number 1. So that test is going to pass. And then here's an example of an asynchronous test. The only difference here is we've added the async keyword in front of the arrow function that contains our test. And so we're doing the same assert strict equal 1 equals 1. So that test is also going to pass. So now let's run those tests. In order to do that, you run node with the --test flag. And you can see here, this is the output that we get from running the tests in our previous example. Now let's talk about recursive file system operations. The built-in methods like fs.readFile and fsunlink are great for working with a small number of files. If you want to work with a large number of files and/or directories, recursive operations are helpful. In the past, doing any recursive file system operations required adding one or more dependencies to your project. Not anymore. So the first fs function we're going to talk about is fs.makedir. In order to use this recursively, you can pass an option in the second argument that just says recursive true. And so here's an example of using that. we can say here make dir slash temp slash a slash b slash c, and then we're passing that recursive flag there. And so that means that's going to create any or all of those directories if they don't exist. So slash temp probably exists, but if A, B, and C didn't exist, it would create all of them for us. Next up, let's look at the fs.rm function. So this function recursively deletes a directory and all child directories and files. So this is probably the feature from this talk that I worked on the most. I should also point out that this feature is implemented based on the rimraf package from npm. So here's an example of using rm. So here we're saying we want to rm slash temp slash a. And if you recall from our previous example, that had some other subdirectories and stuff inside of it. And then in the second argument, we're passing the options recursive true and force true. So this is very similar to the rm-rf shell command. And this will just delete the directory A along with everything else inside of it. Next up, let's look at the fs.cp method. So this method is used to recursively copy a directory and all child directories and files. The implementation of this feature is based on the copy method from the fs-extras package on npm. And here's an example of how this works. So in this case, we're going to copy that directory we created before at slash temp slash a to slash temp slash z. And then again, in the second argument, we're passing recursive true. And so that'll copy slash a, slash b, slash c, whatever else is in that directory. It'll recreate that structure in slash temp slash z. It should be noted that this API is currently marked as experimental, although we do expect that to change soon. Finally, let's talk about the fs.readdir method. This is a method to recursively read the contents of a directory and all child directories. This method currently exists, but it only reads a single directory. So the idea here, again, is to add this second recursive option, which would let you read the contents of a directory and any of its subdirectories and any of their subdirectories and so on. There's currently an open PR for this feature. So this is not implemented in Node at this point, but there is an open PR and we're hoping that it's available very soon. Okay, so what's next? What do I want to see in Node in the future? I should point out that these are just my ideas, not necessarily things that are being worked on or will be worked on. One idea is glob. Glob just uses these patterns, like you can see in the example here, to select multiple files and directories. So in this example, I'm saying I have a directory called packages, and then in every subdirectory inside of that, I want the package.json file. And because I use 2 stars there, it will read subdirectories and their subdirectories and their subdirectories, etc. If I only used 1 star, it would only read 1 level deep. And globs, by being used to select multiple files, work really nicely with recursive file system operations. So I'd really love to see this in Node in the near future. What about self-contained executables? Imagine if you could just run node compile index.js, and that would give you a self-contained binary with the node runtime and your code. Getting rid of the install step when distributing something like a CLI is a great start, but you're still depending on your users to have a compatible version of Node installed. Building a self-contained executable solves that problem too. We've been discussing this on and off for the last few years in the tooling group, but no major progress has been made yet. If you do want to do this today, I'd recommend a third-party package like Boxed Node or PKG. How about TypeScript support? Imagine if you could just run node index.ts and your TypeScript code would work out of the box. As far as I know, this isn't happening yet. I have seen some Twitter conversations about this idea though. Node.js supports custom loaders with ESM, and there is already a loader for TypeScript called tsNode. What if we just automatically use that loader for .ts files? Want to help figure out and build what's next? Join the Node tooling group. You can find everything you need to know about the tooling group and how to get involved at the URL on the screen. Also, feel free to reach out to me directly on Twitter or if you see me at a conference. Putting it all together. So I wanted a way to try out all of these new features. So I started thinking, what's a CLI app that I could build that makes API requests, downloads files, and manipulates the file system? And then it hit me, a package manager. So let's build a package manager? Introducing Bad Package Manager, or BAD for short. It's a package manager that is bad for science. One day, this might be a good CLI app. It will probably never be a good package manager, though. So this is an ongoing project that I'm working on to test new features in a Node.js CLI app. And it currently uses parsargs, fetch, the built-in test library and runner, as well as the recursive versions of RM, CP, and makedir. Other contributions are welcome. You can find the Bad Package Manager on my GitHub account, and I've included the URL there. Let's take a look at what features the Bad Package Manager currently supports. Bad install will install all dependencies and dev dependencies from package.json. Bad install package will install the name package and add it to dependencies in package.json. There's also bad install --dev package, which will install the name package and add it to dev dependencies in package.json. And there's a bad clean command, which will delete the node modules directory. I also have some future ideas for this project. I'd like to add a bad uninstall package command that will uninstall a previously installed dependency or dev dependency. I'd also like to add bad run script to run the script specified in package.json. And I'd like to add a bad ls package command to list part of the package tree, hopefully using the new fs.readdir recursive method when it's available. And what else? I don't know. If you have ideas, please feel free to open an issue or submit a PR to the project. Once again, you can find the Bad Package Manager on my GitHub account. It's ensu/bad-package-manager. Well, that's all I've got for today. Please reach out on Twitter or GitHub if you have any questions or feedback. Thanks for watching.